So redundant array of inexpensive drives, also known as RAIDs, they allow us to create a logical hard disk drive from 2 or more physical drives. So if I buy, 2 or 3 1 terabyte hard drives, I can put them together in a configuration of like a RAID 0, a RAID 1, or RAID 5, or RAID 10, and have them give me either better speed or better redundancy than a single drive by itself could. This is called a RAID, and usually they're going to be hot swappable as well because you're going to be using SATA as your backbone to your RAID. So the first two we're going to talk about is a RAID 0 and a RAID 1, and they kind of form the foundation of RAIDs for us. So a RAID 0 has 2 drives that act as one single drive. As you can see from the picture here, they use what's called striping to increase the performance and speed. So if I take file A, which actually is 8 parts make up that file, I put the evens on disk 1 and the odds on disk 0. The drives now are sharing the load of accessing that large file. The problem with this is if you lose either one of those drives, you just lost half the file, which means the file is now inaccessible. So there's no redundancy with a RAID 0. It's all about speed. You get better speed and better performance. With a RAID 1, you can see that we have identical copies of all parts of the file on both disks. So we have perfect redundancy. We often call this a mirror because every time it writes to one disk, it writes the same thing to the second disk. You don't get much performance boost here, but you do have instantaneous backup here, and it's not nearly as fast as a RAID 0. So if you care about redundancy and backup, you want to have a RAID 1. The next one we have, so it's called a RAID 10, also known as a RAID 10. Then the reason it is because it's really a RAID of arrays. This one, you're going to have at least 4 drives, because as you can see in the picture here, we have a RAID 1. We have 2 different RAID 1s, getting us 2 separate disks, and then across those 2 logical disks, we've used them in a RAID 0 configuration. So we have redundancy between disk 0 and disk 1, and then we have redundancy between disk 2 and disk 3. And then between those 2 logical arrays, we're going to end up using a striping across those arrays as well, which then gives us that speed boost that we're looking for. So here we use 4 drives and we get speed and redundancy. It does allow us to do hot swappable. So for instance, if disk 1 died, we can pull disk 1 out, put in a blank disk 1, and have disk 0 copy over to disk 1 to rebuild the array. RAID 5 is probably the most common RAID you're going to come across in the field. This is the one that we use all the time. It requires a minimum of 3 drives. In my picture, I actually have one that has 4 drives. And what it does is it uses striping across the drives, but it also calculates what's called a parity bit. And so as it's putting the data across this array, if one of the drives fails, it can use the parity to calculate the missing portion from that drive. So as you can see here, we have part A1, A2, A3, and then AP is the parity. On the next one, you can see that parity moves to the left one drive, and so it stripes across the array. If we lost, for instance, drive 0, we could recalculate part A1, B1, C1, and D parity by using disks 1, 2, and 3. And so in a hot swappable environment, I could yank out disk 0, put in a blank disk 0, and it will rebuild the array back across the stripe. The nice thing about that is it minimizes your downtime, right? If we have a server environment, we don't want to have to shut it off because that's going to impact a lot of users. By using these RAIDs and this hot swappable rebuild capability, we can still keep moving. RAIDs can be done either using PATA, which is the older style, or SATA, which is the newer style. SATA RAIDs are going to be much faster and much more resilient. They're going to use a hardware controller, either a separate card or the motherboard. Or you can do them as a software RAID. When we get into Windows next week and we start dealing with operating systems, I'll show you how to do that in Windows from a software RAID. In the BIOS, we can also do hardware RAIDs, which is hardware RAID is better than a software RAID for most uses. A hardware RAID is going to require you have at least 2 drives, 3 if you want to do a RAID 5, 4 if you want to do a RAID 10. And you have to have a RAID compatible motherboard that supports it. You can see here in this BIOS, you go to the SATA mode selection, and you change it from IDE down to RAID, and that will turn on the RAID controller in the motherboard, and then we can set it up from there. The software requires a disk array in Windows using disk management software, and again, we'll talk more about that when we get into Windows next week. And so which of the following would require a minimum of 4 hard drives? So which one requires 4 hard drives? D, RAID 10, right? Which one requires 3? RAID 5, right? Which one requires 2? RAID 1 or RAID 0, right? Yeah, so if you know your minimum requirements for RAIDs, and you understand speed for RAID 0, redundancy for RAID 1, speed and redundancy for RAID 10 and RAID 5, you've got a good handle on what RAIDs are for this exam.